Hello everyone, I'm Paul and today we're solving problem 3439, reschedule meetings for maximum free time 1. This is another medium interval problem and this might be tricky honestly, so here I will show you how to solve this visually and then we'll go with the code. So let's start. This is a long description, but basically we are in an event and we have some meetings in this event. And we are given two integer arrays, start time and end time. And in these arrays, we have the start and end times for every meeting. We are also given an integer event time, which corresponds to the duration of the event. And we are also given an integer k. We need to return the longest continuous period of free time during the event, considering we can reschedule at most k meetings. Now there are a few things to consider here. These meetings are non-overlapping and we need to preserve the relative order of the meetings, meaning we can't sort meetings. And of course we can't reschedule meetings to a time outside the event. Now there are a lot of things to consider here, so I will try to explain this visually. Let's say we are given this input. These are the start times, these are the end times. The time for the event is 10 and we can reschedule at most one meeting. So this is the visual representation of the input. For example, if we take this, the first meeting goes from 0 up to 1. The second meeting goes from 2 up to 4, okay? And so on. The time for the event is 10, this is the maximum time, and we can reschedule at most one meeting. Now, I don't know if I've mentioned this, but of course we need to maintain the original duration for every meeting. So here the solution is to move this meeting one step to the left. So now this meeting is here. And by doing this, now we have 6 free spaces here. So in this case, we return 6. Now here we have 3 choices. We can move this meeting, we can move this one, and we can move this one. The question is, why are we deciding to move this one? Well, because here we have no spaces to the left and 1 space to the right. So we have 1 space in total. Here we have 1 space to the left and 5 spaces to the right. So we have 6 spaces in total. And here we have 5 spaces to the left and 0 spaces to the right. So we have 5 spaces in total. So we find the maximum amount of spaces surrounding a meeting here. The number is 6. That's why we decided to reschedule this meeting. So we already see a pattern here. When we are checking for this meeting, for example, we are looking at this range. When we are looking at this meeting, we are actually looking at this range. And when we are looking at this meeting, we are looking at this range. Now let's say we have this input. These are the start times, these are the end times. The time for the event is 12 and k is 2, meaning we can reschedule at most 2 meetings. Now the main difference with the previous example is that here k is 2. And there's one big observation we need to make here. If we decide to reschedule this meeting, for example, it doesn't make sense to reschedule this meeting. Because remember, we're trying to find the maximum continuous period of free time. So if we decide to reschedule this, we should also reschedule this. Similarly, if we decide to reschedule this, we should also reschedule this or this. If we decide to reschedule this, we should also reschedule this or this. And if we decide to reschedule this, we should also reschedule this. So with this in mind, we can do sort of like a sliding window, where the window has a size of k plus spaces. So for example, if we take these 2 meetings, the window will have this size. And once we get the size of this window, we can just subtract the amount of time for the meetings, and this is how we get all the free time. In this case, we have 1, 2, 3, 4, 5 spaces for free time. So this window goes from 1 to 10, so we do 10 minus 1, this is 9. And here we need to subtract the time for these meetings. This meeting has a length of 2 and this meeting has a length of 2, so we subtract 4 from here, so we have 5 spaces of free time. So we will get a 5 if we move these 2 meetings all the way to the left or all the way to the right. If we reschedule these meetings here we have 5 continuous free spaces. And if we reschedule these meetings here in this side, we also have 5 continuous empty spaces. So we will check here every group of k continuous meetings plus spaces. So we start from here with these 2 meetings plus spaces. So here we do 6 minus 0 to get the total range, and then we need to subtract the time for the meetings, meaning 1 plus 2. So we subtract 3 from this, meaning here we have 3 free spaces if we move these 2 meetings either to the left or to the right. So the result up to this moment is 3. Now we are taking these 2 meetings plus spaces, and remember that the count here is 10 minus 1, this is 9, and here we need to subtract the time for these 2 meetings, and 9 minus 4 is 5. 5 is greater than 3, so now the result is 5. Now we are checking these 2 meetings plus spaces, meaning all of this, and here we need to do 12 minus 4, so 12 minus 4, this is 8, and we need to subtract 2 plus 1, meaning 3, this is 5, and 5 equals to the result, so now we return 5. Now there is one last problem here, and it's that we need an efficient way to check what is the total amount of time we are using for meetings at each step. In this case, the time for meetings is 3. But remember, we are iterating this entire thing, so we can't just calculate the time for every meeting at each step. For example, when we were here, we needed the time for this meeting, and now we are here, and we also need the time for this meeting, so we are repeating work here. And luckily for us, there is one way in which we can keep track of the time for meetings efficiently, and this is with prefix sum. Now, in case you know what prefix sum is, let's say we have this array, and we will create our prefix sum array. We start with the first element in the array, and each of the next elements will have the sum for every element up to the corresponding element. So right now we are here at this index. So now we will take the sum of 1 and 2, and we put 3 here. Next we have the sum of 3 and 3, so we put 6. Finally, the sum of 6 and 4 is 10. So this is our prefix sum array. Now let's say this is the array, and we are trying to get the sum of the elements in this range efficiently. Well, we can use our prefix sum to get the sum of every element up to this point and subtract the sum for every element up to this point. This is how we get this, meaning this is how we get this. Now what this means here is if we are trying to get the sum of these two elements, we can take the prefix sum up to this index, meaning 6, and subtract the prefix sum up to this index, meaning 1. So 6 minus 1 is 5. And the sum of these two elements is 5. So we'll use this technique to get the times for meetings at each step efficiently. Now, with all of this in mind, let's go with the code and hopefully you will get the idea. First we'll say n equals length of start time, result is 0. Now we are building the prefix sum for meeting times. So we'll call this pre. This is initially an array, and the first value of this array will be end time at 0 minus start time at 0. And now we need to fill this prefix sum. So for I in range from 1 up to n, pre.append pre at -1, meaning the last value in the array, plus end time at I minus start time at I. And now we can say for I in range from k minus 1 up to n, remember the window should have a size of k plus spaces. So we start from k minus 1 and we will set a left pointer, which will be end time at I minus k if I minus k is greater or equal to 0, else 0. What this means is we are taking the end time at I minus k, but if I minus k is out of bounds, meaning if it's smaller than 0, we take 0. This is left. Now we'll set a right pointer, and this is start time at I plus 1 if I plus 1 is smaller than n, else we take the event time. This is the same logic. We are taking the start time at I plus 1, but if I plus 1 is out of bounds, meaning if it's greater or equal to n, we need to take the right bound, meaning event time. And now we will take the total duration of meetings, and this will be prefix sum at the current index minus prefix sum at I minus k, but if this is out of bounds, we should take 0 here. So we can say we take this if I minus k is greater or equal to 0, else we take 0. And finally, result is the maximum between the result and right minus left minus total duration. And now we return result. So this is it for the code. Now let's submit this and see if it works. As you can see, this works and it's very efficient. Time and space complexity for this approach is big O of n. And if you found this useful, please drop a like, subscribe, and see you in the next one. Bye bye.